Hi everyone, and sorry I wasn't here the past couple of days. I'd like to just go through some of the notes that you missed from Monday and Tuesday to make sure everyone is caught up. So today's lesson is on solving rational equations. So remember that when we did addition and subtraction last week, we found a common denominator and then added or subtracted the numerators to find the answer. Well, one of the most common things that people say in this section is when we go to solve an equation, we want to actually get rid of the denominator because we're solving for x. We're trying to get x isolated. So many times there's some confusion about the differences between addition and subtraction of rationals where the denominator stays, and in this situation where we want to get rid of the denominator. So if you recall that in grade 10 when you were doing slope, you could sometimes get rid of the denominator by looking at the common denominator. For example, if you had 1/2 plus 3/5 equals x, let's say. Well, you could decide to get rid of those denominators by making this what's called an equivalent equation. So to make an equivalent equation, you find the common denominator, which in this case is 10. So we would multiply each piece by 10. But when that happens, if we multiply this piece by 10, well, you can do some simplifying. 2 fits into 10 5, 5 fits into 10 twice. So you'd end up with 5 plus 6 equals 10x. That's an equivalent equation with no more denominators, okay? Or even simpler, you can just find out the piece that's missing, which in this case 5, so then you don't have to worry about simplifying. Always remember, this is an important one, check your answers because there could be some extraneous roots, okay? So here's what an example of a rational equation looks like. You could have variables on either side. You could have a number on one side and you're solving for an x. You're going to have sometimes ones that are linear and some that are quadratic to solve, okay? The steps are here, and I'll be going through and referencing these steps as we go through. Okay? All right, so here's the first example that I'd like to show you. So in this case, it gets very tedious as we start multiplying by the common denominator. So that's why I start to shorten up as we go through by just multiplying by the piece that's missing. So if I look at this problem here, my common denominator is 4x. So I'm multiplying each part of the recipe. If you think of it like a recipe, flour, sugar, chocolate chips. You need to do the same thing to each ingredient in order for the chocolate chip recipe to taste the same. So when I multiply 4x by x over 4, the 4's will cancel, and you're left with x squared. In this case, we're trying to get rid of denominators, remember, so that's why I'm allowed to do this. The x's will cancel. Nothing cancels in that one. We will finally have x times x, which is x squared, negative 4 times 7, negative 28, and 12x. Bring everything across so that it becomes a quadratic. I brought my 12x over to become negative 12x. I said, what's going to multiply to give me negative 28 and add to give me negative 12, negative 14, and 2. So then I will factor that and solve my equation, x equals 14 or x equals negative 2. We want to make sure that's not a non-permissible, which in this case our non-permissible is x is not allowed to be equal to 0. Even though those both work, you should always double check by checking your answer to see if it works. 14 divided by 4 minus 7 over 14 should equal 3. Let's just check to see if that works. 14 fourths minus 7 over 14 should equal 3. Well, 14 fourths, that's going to reduce down to, we can divide 2 by each of these, 7 over 2. And 7/14 is the same thing as 1/2. 7 take away 2 is 6 over 2, which is equal to 3. That checks. We should do the same thing for negative 2, negative 2/4. That works out to be the same, so let's check it over here. Negative 2/4 subtract 7 over negative 2 equals 3. Well, let's see, this reduces down to negative 1/2. And this is the same thing as saying plus 7 over 2 because we have two negatives there. So negative 1 plus 7 makes 6 over 2, which is 3. 3 equals 3. Left side equals right side. We're right. They both work in that case. No extraneous roots. All right, so let's try this one, example number 1. Remember, the first step is to always factor your denominators to find the common denominator. So as I'm going through, I'm looking for the different types of factoring. This first denominator is difference of squares. Z minus 2, Z plus 2. When I look at the second denominator, the type of factoring there is a common factor. So I pull out the 6, and I'm left with Z plus 2. And over here, nothing can be done. All right, so again, I'm not trying to do addition or subtraction like in our last section, 6.3. This is solving. I want to isolate for x, which means I want to get rid of my denominator. So if I'm looking for a common denominator here, I think about all the pieces that I need. A z minus 2, a z plus 2, and a 6. So this piece is missing a 6. Now I could show all the work of that I'm multiplying it by the common denominator. It just gets very tedious. I'm going to multiply that 2 by the common denominator, which you'll find that those are just going to cancel out anyway. So you'll just be left with the 6 times 2. So I'm not going to bother showing that. It's just going to be too much paper. So in this problem, I'm just going to do the piece that's missing, which is the z minus 2 times 10. And over here, what's missing is a 6 and a z plus 2. Okay? Oops. Now, I don't need to worry about, let's just take that out because I'm going to get rid of those denominators in the end here. So we'll just be left with the numerator part. So 6 times 2 is 12. And over here, I'm going to get 10z minus 20 and 6z plus 12 when I apply the distributive property, remember? That's how I got those. Now I'm going to gather up my like terms. So in this case, I will put the 12 and the negative 20 together. I'm going to move. In this case, it's going to be linear. So let's get all of the variables on one side. That would leave me with 12. So let's just go negative 8 plus 4z equals 12. I'm going to add the 8 to this side. So you're left with 4z equals 20. Solve for my z. Z equals 5. Now, just going back here, I should state my non-permissible values after I finish factoring. So z is not allowed to be plus or minus 2. 6 is not a variable, so it's not a non-permissible. The only non-permissibles have to do with the variables, what's going to make the denominator be 0. All right, and so my answer is 5, so I should always double check to see if that works. So as a check, let's go over here and do the check. So 2 over 5 squared minus 4. Is that what it was? 5 squared minus 4 plus 10 all over 5 plus 2, right? No, 6z plus 12, right? 6 times 5 plus 12. And that's supposed to equal 1 over 5 minus 2. All right. 2 divided by 5 squared is 25 minus 4 is 21 plus 10 over 30 plus 12 is 42 and 1/3. So let's reduce this down. These can both be divided by 2. So 2 over 21 plus 5 over 21 is equal to 1/3. 2 plus 5 is 7 over 21, which is 1/3 when you reduce it down. 1/3 equals 1/3. Check. Works. All right. And now you should have tried one on your own. You can pause the video here while you try this one on your own. The answer to this problem is non-permissible is 3 and 6, and your answer for y is 12. Okay? And you can try those in your book. Any problems, you can let me know in class. Now, this one will have an extraneous root, one that will not work. So, remember the first thing we want to do is simplify all of our denominators. So, nothing to simplify there. And nothing to simplify in the second term. But this one does have a difference of squares, so I'll factor it. K minus 2, K plus 2. So now we can see our common denominator, which is K minus 2, K plus 2. So if I multiplied the numerators by those common denominators, you would find that the K plus 2 part would cancel out. We'd just be left with the K minus 1. So I'm only going to show that part of it. So we're going to do the K minus 2 multiplied by 4K minus 1. And this piece is missing a K plus 2, so I'm going to multiply that by K plus 1. And this one doesn't have anything missing, so the denominators will just cancel, and you'll be left with just the numerator. All right. At this point, we should have stated our non-permissible, so K is not allowed to be plus or minus 2. We'll keep moving. Now we need to apply the distributive property so that we can collect all of our like terms and solve the quadratic. Okay, so that's going to leave us with 4K squared. That's going to be, if you do the outside terms, a negative K and a negative 8K, so altogether you have a negative 9K plus 2. Subtract, I'm going to use a bracket here to make sure I don't mix up any negatives. K squared, a K and a 2K makes 3K plus 2. K squared minus 4K plus 24. Keep working to gather up your like terms. 4K squared, subtract the K squared will leave me with 3K squared. Negative 9K, subtract 3K, or you're thinking about keep switch switch. Negative 9 plus a negative 3, which leaves you with negative 12K. Positive 2, subtract 2. It's like saying positive 2 plus a negative 2, which leaves those will cancel each other out. And at the same time, I'm going to move all of these pieces over to the left-hand side, since it's quadratic, so that will become a positive 4K, and this will become a negative 24, and it will equal 0. Keep gathering your like terms, so you're left with 2K squared, negative 12K plus 4K, negative 8K, and negative 24 equals 0. I can pull out a common denominator here of 2. k squared minus 4k minus 12 equals 0. And now we should be able to factor. If not, we'll use the quadratic. But what multiplies to give me negative 12 adds to give negative 4. That works. K minus 6 and k plus 2, which means my two values are k equals 6 and k equals negative 2. Now, we should realize at this point, because of our non-permissibles, it says k is not allowed to be plus or minus 2. So this one is out. It's an extraneous root, and this is the only one possible. And of course, you should always check it with a mental double check, okay, by plugging it back into the original formula. Okay? Again, let's pause the video right here, and you can try that question on your own. Check, make sure there's going to be an extraneous root. And the answer? X is equal to 5/3. X is not allowed to be negative 2 and 3 for the non-permissibles. And again, you can try these ones on your own at home. And that's the end of lesson part 1 of 6.4.